Welcome to Bravel Institute. In this class, we are discussing about Kolmogorov's forward differential equation. How to calculate this forward differential equation and how to derive this equation, and finally how to utilize this equation in our calculation. For that, we considering Chapman-Kolmogorov's initial equation. We know that this is one ith state and jth state. We considering two states I and j. So probability of here it is a Pij. Probability to reach ith state to jth state is Pij. Again, we are introducing one more term. It is called kth state. It will call kth state. So we introduced one more term. From here to here, time is taking s. I to kth state. I is jumping to kth state. It is taking s time, and k to j it is taking t time. So our total time t to ij is t plus s. Our total time is equal to t plus s. So how to write the Chapman-Kolmogorov equation? P of ij t plus s. T plus s is equal to sum of k element of s. Probability of P of ik time s and P of kj at time t. So we are multiplying probability to I to k and k to j. So final probability I to j is getting by multiplying ith state I to k and k to j. This k means some more terms, k or l or whatever may be. We can go through I to l or to j. We can introduce number of intermediate state. That's why k element of s, probability of I to k at the time of s and k to j at the time of t. This is our Chapman-Kolmogorov equations we already learned in previous class. Now we are dividing from this equation to our forward differential equation. For that, we considering I to k is the time is t. It is taking t time, and k to j is taking, this is a time t, and k to j it is taking small time interval h. Why it is a small time interval? We are reaching, for example, we are reaching, it is taking 0 to 60 minutes. So 1 hour is taking probability I to j in at least 55 minutes. We taking I reaching to k. Then another small time we reaching to j. So we started from I and j. We reached here, it taken 55 minutes of time, and another 5 minutes we reached it from k to j. So we considering I to k it is taking time t, and k to j it is taking small time interval h. Then how to write this equation? Probability of I to j t plus h is equal to sigma k element of s. So same way, p of ik the time t, p of kj at time h. So this is a small time interval. We are multiplying same probability to reaching here, multiply probability to k to j. So this is our first equation. This is our first equation. we are deriving Kolmogorov forward equation, differential equation. We initially start with the Chapman-Kolmogorov equation and derived from P of ij t plus h. Considered time is equal to t and h. We return the equation P of ik to t, kj to h. Again, one more thing, k element of s. This k is element of s. We are going to split k not equal to j and k equal to j. We are going to split this k element of s is going to split k not equal to j and k equal to j. That means we are considering all the intermediate state here, L, whatever state M, whatever state is there, we are considering all intermediate state. And we are directly P of ij. There is a one more probability is there, P of ij, direct probability, and continuing here. We'll write the equation, we'll understand more. Now, P of ij t plus h equal to sigma k not equal to j. In this state, we are not considering here P of ik same t P of kj h. There is no change, but we are not considering it's a j. Then how to write? Separately, we have to write k element of s is divided into k not equal to j, k equal to j. So here P of ij time t, P of jj at the time h. So what happened? Initially we considered all the process, I to j, I to k, everything considered here, k element of s, all subsets we considered here. Now we split it. K element of is split to k not equal to j. First we can write is a k to j, I to k and j, I to l and m to j. All the subsets we can consider here except this one. This one is considering separate for our equation. What is this one? P of ij t, P of jj. We are in the state of I directly moving to j. We are in state of I is directly moving to j and continuing here. So at the time t, we moved I to j and small interval of h time we continued here. For example, everybody is doing everybody is traveling different places. Whenever we book flight, we will get a ticket. For example, we booked a flight from London to New York. So we have many options. We can go through Canada, we can go through any other country, Mexico, any other city of some other city, and we can move to New York. We have a lot of options. Once you booking flight, we will get many options to reach in New York. But we have one more option, direct option also is available. So we are moving directly and staying here. This may take a more time, but here we are moving directly and staying here. Like that, here many options are there to reach to J. Here all the options we are reaching to New York. Same way, we have many options. All the options we are going here and reaching here. But we have a direct option also. Of ij and continuing small time we are continuing here. So this one we taking separately. So P of ij t and P of jj h. Now we have to write this two probability we have to consider. What is the P of kj h? This one we learned in generator matrix P of jj h. These two terms we already learned in the generator matrix. In assumption 2, Markov assumption 2, talking about P probability of K to J at small time interval, we can write mu of Kj plus OH. This one we already studied in Markov assumption, and in generator matrix we already learned this equation. What is this equation? Probability of K to J is a time H. Time is taking H. Time H, we are our probability is equal to K to J. So we are multiplying this two. This is our Markov assumption. We have to multiply small interval time to transition rate. What is mu kj? It is a transition rate from K to J. So probability to reach K to J at small time interval, we can multiply small time into transition rate h into mu kj. OH is a correction terms because there is a lot of intermediary state. Another one. So this is our equation 2, and another one, P of JJH. What is P of JJH? We reached here and we are continuing here. So that one is, we can write P of 1 plus H into mu JJ plus OH. 1 plus H into mu JJ plus OH. This one is getting from generator matrix. You just check our videos in generator matrix. One more video is already uploaded. Generator matrix. So we check how to get a PJJ is equal to 1 plus H into mu JJ. This mu JJ means sum of the transition is coming out from the J. Sum of the transition minus of sum of the transition come out from the J. So what are the transition is come out from the J? In this state there is no transition because this is J is a absorbing state. But in any other situation, there is some transition come out from J to Z or J to M. Some transition will come out from the J, or it is returned back to I, or there is a return back to I, J to I, like that. So we have considering transition in J to J is equal to minus of sigma mu Ji. So it will be a 1 minus. So we have to subtract 1 minus this one. H into sigma of mu Ji or something. We are not taking this one. We are considering only this equation only. We are substituting this one in here. We are, what is the value of 1 minus this one? We already learned in the generator matrix how to write. Whenever solving the problem, I'll explain what is a mu Jj. So we received two equations. One is P of Kj H is equal to H mu Kj, and P of Jj H is equal to 1 plus H into mu Jj. So we received two equations. This both equation we are substituting here. This one is here and this is here. We are going to substitute these two equations in their place. P of ij t plus h is equal to sigma k not equal to j. K not equal to j, our equation is P of ik t into, here we are substituting this equation, h into mu kj plus another one P of ij t, and we are substituting this equation 1 plus h into mu jj plus OH. OH is a current term, is both equation is there, so we are taking OH. So 1 plus j. Then next steps. So this is our second equation. We substituted this two equation to here. So we initially we understood how to write t plus h if ik and kj, and we split k not equal to j, and here it is a k equal to j if ijt ijj. and small time interval pkgh we can write as a transition rate. Writing time is multiplying with the transition rate. This is getting from assumption, Markov assumption 2, and the generator matrix we already learned this equation. This both equation we substituted here, so we got this equation. Now we are solving to differential equation. We are going to find out what is our differential equation. So for that, so our equations is in our, now we are going to solve our differential equation. So for that we multiplying p of ij to 1 and p of ij to h into t. Both the term we are multiplying, we will get p of ij t plus h is equal to k not equal to j p of I k t h into mu kj plus p of ij we multiply it to 1 and we multiply it to here plus p of ij t h into mu jj plus our OH. So our equation we multiplied p of ij to 1 and p of ij. Next we are taking p of ij term to left hand side. So taking p of ij to left side, it is a p of ij t plus h minus is taking to here p of ij to t is equal to k not equal to j p of I k t h into mu kj plus p of ij t h into mu jj plus OH. This is our equation. So we taken p of ij t to our left hand side, we received like that. Next step we are dividing to, we are going to divide h, all the terms. We are going to divide h, here h, here h. Time is divided, then we can cut like that, cut like that. H is divided into all the terms and we are giving to limit. Limit h tends to 0. Limit is giving h tends to 0. Then what will happen? H tends to 0. So this is equal to k not equal to j p of I k t mu kj plus p of ij t mu jj. So our equations become like that. This term is going to become 0. Once is giving limit, then this terms will become 0. So this h is already removed and our equations become like that. This is k not equal to j p of I k t mu kj and p of ij t mu jj. Now what will be this term? How to write this term? This is our differential, partial differential equation. We can write d by dt of p of I to j time t. This one we can write, this is a partial differential equation, p of ij t plus h minus p ij t divided by h. We are giving limit h tends to 0. We can write d by dt of p of ij into t. Then what will be the here? Here we already split. How you split the k element of s is split to k not equal to j and k equal to j. So we k equal to j we got like that, k not equal to j considered here. Now again we are removing these two terms and we are writing k equal to j. So now we considering k is considering all the subsets, k element of s, p of I k t and b of kj. This is our equation. Because here k not equal to j, that's why considered separately. Here it is considered separately. This one is splitted here like that. K not equal to j and this is k equal to j. Now this both is included here. K element of S. We taken k element of S, then P of ik and mu kj. So this term is already here. If k is equal to j, P of ij and P of jj. If here k equal to j, what will be k equal to j? We can write P of ij and P of jj. So this term is already included here. So our forward differential equation, this is our forward differential equation. K element of S, P of ikt into mu kj. So probability of reaching to ik, this will take a more time multiplying the transition rate. Mu kj is a transition rate is multiplying with the probability of I to k. What's the time is taking t to reach I to k, and we are multiplying transition rate. So this is our calculation. Please note down. For more about any doubts or for more about to know calculation, kindly visit www.bravelinstitute.com. Kindly visit our website www.bravelinstitute.com and subscribe my channel to support me. So our d by dt of our equation j into t, this is our equation. This is our forward differential equation. To understanding more about this equation, I am taking 2-3 problems. First one is HSD model. Writing on HSD model. HSD model. So HSD model is a health, sickness and dead. So healthy to sick state is a sigma, and here to here it is a rho. Here to here it's a mu, and here to here it is a nu. This is a transition rates. These all are transition rates. HSD model, H to S transition rate is sigma, and S to H transition rate is rho, H to D mu, and S to D it is gamma. We can write mu HS, transition rate H to S is sigma, and mu S to H is equal to rho, and mu H to D is equal to mu, and mu S to D is equal to mu. Our transition rates. And how to write the our generator matrix? We already learned how to write generator matrix. This is our generator matrix. H S D. H S D. So H to H, we have to take a sum of the all transition come out from here. It is a wrong. This is a here. So H to H and H to S, we know H to S, our transitions are sigma, and S to H and H to D. So two transition is come out from H. Two transition is come out from H. H to D is mu. So what will be here? H to H, it is a sigma plus mu. So sigma plus mu. So this is a H to H is a total minus of total transition come out from H. So one is sigma and other is mu. So minus of sigma plus mu. And S to H, we know this. Our transition is rho, and S to D, we know the nu. Then what will be our transition S to S? Rho plus nu. And there is 0, there is no transition come out from here. Now we are going to find out, they are asking about d by dt of P of H to H at the time t. What is the P of HH at the time t? So this is the Kolmogorov's forward differential equation. They are asking to solve for Kolmogorov's forward differential equation. So our equation is HHT. Here is asking instead of I and J, here it is H and HT. So how to write? We have two options. Many options is here. So initially we are in the state of H and finally we reaching the state H. So initially we are in the state H. First option, initially we are in the state of H and we are continuing the H, we are reaching the H. So in this option, we are in the state of H and there is no movement and we are continuing the H. So we have H to H. You can write here P of H to H at the time T, we continue in the same probability of reaching the same state. And H to H, it's a transition is not happen. It is a mu of HH plus one more probability is there. Second option. What is our next option? At the time T, we went to S. At the time T, we went to S. Then at that small time interval, we return back. Check it out. We are in the state, initially we are here and taken time T time, we reached in state of seek and we recovered. So small time we stayed in the state of seek and we recovered and returned back to H. So for us in the total time we are in the state of healthy only. So this is a P of HS T and mu of S to H. Not down, always it is start from H reaching 5. We are starting from initially H and finally reaching to H. So here also we are starting from H and to reach in H only. Always will be initially from H and final should be H because here H and H. One more option we can consider, but it's not. We are in the state of H and moving to D and moving to H. We are in the state of H moving to here and moving to here. This option, how to write, plus P of H HD time T and mu of DH. So this is a third option. Third option not is valid because we are reaching to D. There is no return back to H. It's absorbing state, that state, we are not returned back to H. So this option is this transition, this equal to 0. There is no transition. This option we cannot consider. So this term is removing from here. So we have two options. We return P of HH and mu HH, probability of HS and mu SH. We know the values. We know the values of mu of HH and mu of SH. What is mu of HH? We know it is a minus of sigma plus mu. This is equal to minus of sigma plus mu. What is SH? Mu SH. S to H, it is a rho. So we are writing d by dt of P of HH T is equal to P of HH T into minus of sigma plus mu plus HST into this equation is 0. So this is our equation. This is our equation of d by dt of probability of H to H at the time T. So P of HH time T into minus of sigma plus mu plus P of HST and rho. So this is our equation for P of HHT. Next we can write like that. P of HST. One more terms we are considering. P of SH. P of HS. HST. What will be forward differential equation of probability of HST? Initially we are starting from H and finally reaching to S. So what are the probabilities are there? We can First option, what will be our first option? We are in the state of healthy state. Initially, we are in the state of healthy state. So our option is healthy state. And we reaching to the time of t, we reached S. And a small time interval, we continued here. So this option we can write a probability of HS t into mu SS. Initially, we start from H and we reached S. Then we continued S. What is another option? Another option, initially we are in the H and we continued in H, then we transition is happened from H. So what will be that equation? Plus H T mu Hs. This is our second equation. Second option. What will be the third option? We are in the healthy state, is moved to death state and moving to sick state. This is option is not possible. We no need to consider because H to D, D to sick. This option is not possible. So no, we are not considering this option. So this is two options are there. Initially your Hs directly passed to S and continuing here. And initial time at the time of T, we continued H to H. Then we transition is happened to S. So this is our two equation. So what is our mu SS? Mu SS and mu HS. We know P of HS T. Mu SS continuing here. It is a minus of rho plus nu plus P of HHT mu HS. What is HS? Say sigma. So this is our equation. Probability of H to S, we considered two options, H to S, then we continue here. Initially we continuing H to H, then a transition is happened. So this both mu SS and mu HS we can substitute our generator matrix values, then we got like that. So more about to know about more these problems and calculations, kindly visit www.bravelinstitute.com and subscribe my channel. Any doubts you can send a mail also, bravelinstitute@gmail.com. Thank you.